Past Atlantic hurricane seasons almost seem like a foreign climate, an expert says. Hurricane Beryl, the Atlantic Ocean's first hurricane in 2024, began roaring across the Caribbean in late June, wreaking devastation on Grenada and other windward islands as it grew in power. It's now swirling on like a buzzsaw toward Jamaica and Mexico's Yucatan Peninsula. Beryl is a record-breaking storm, commanding attention in a year already filled with record-breaking climate events. On June 30th, the storm became the earliest Atlantic hurricane on record to achieve Category 4 status. Just a day later, it had intensified further, becoming the earliest Atlantic storm on record to achieve Category 5 status, with sustained winds of about 270 km per hour, according to the U.S. National Hurricane Center in Miami. As of late July 2nd, the storm has weakened slightly but remains a powerful Category 4 ahead of making landfall in Jamaica. Fueling Beryl's fury are the superheated waters of the North Atlantic Ocean. Numerous teams of scientists have predicted that 2024's Atlantic hurricane season would be hyperactive as a result of that record-breaking ocean heat, as well as the pending onset of the La Niña phase of the El Niño Southern Oscillation, or ENSO, climate pattern. Predicted or not, scientists are still agog at the stunning satellite images of Beryl, and the swiftness with which the storm gained power, expert says, an atmospheric scientist at the University of Miami. Science News talked with McNoldy about hurricanes, ocean heat, and what to expect for the rest of the Atlantic season. I'm looking at these satellite images, and this ocean temperature data, and I'm stunned. Anybody who's been looking at this stuff is amazed, an expert says. It's just off the charts, to be at the end of June, early July, and the ocean has more heat content than it would at the peak of the hurricane season. And we're far from the peak. So let's talk ocean heat. We knew, even last year, that 2024 was likely to break records. What are we seeing now? This year, the whole tropical Atlantic has been warmer than average, both in terms of sea surface temperatures and ocean heat content. In terms of ocean heat content, if we're just zooming in on the Caribbean, which is the relevant part for this hurricane, it is easily at a record, he continued. The ocean heat content now looks more like it normally would the second week of September, at the peak of the Atlantic hurricane season. The swath of the North Atlantic Ocean where most of its hurricanes form, known as the main development region, was primed with superhot waters to fuel powerful storms even before Hurricane Beryl began to organize. The region's ocean heat content, a measure not just of temperature at the ocean's surface but extending deeper into the water column, has been higher than ever measured before in 2024, even surpassing 2023, which was the previous record holder. The average ocean heat content for the main development region from 2013 to 2023 is shown in blue. What's the difference between sea surface temperature and ocean heat content? Sea surface temperature is nice and self-explanatory, it's just the temperature right at the surface of the ocean. Ocean heat content is a measurement of how deep that warm water goes. It can be measured in a few different ways. The data I'm processing to analyze ocean heat trends calculates ocean heat content based on temperatures that are 26 degrees Celsius or higher. That's a very tropical cyclone-oriented number. Generally we think of hurricanes being able to form and maintain themselves with water temperatures at 26 degrees Celsius or higher. If water that warm is just skin deep, the ocean heat content is very, very small. But if that warm water goes a lot deeper, the ocean heat content is large. Why does ocean heat content matter for hurricanes? For storms like Beryl, very strong storms, if it were moving over a part of the ocean where the warm water was skin deep, it would easily churn up cooler water to the surface, which can reduce its intensity. But in this case, I kind of doubt we're going to see much of a cold wake, because the warm water is so deep, it's just going to churn up more warm water. The hot waters go down to probably about 100 to 125 meters deep. Storms don't even churn up water that deep. Last year we were also seeing record-breaking heat. What's different this year? Yes, in 2023 we had very anomalously warm ocean temperatures also, not as warm as they are now, but at the time, we were amazed. But we also were getting the onset of a very strong El Niño. That at least put the brakes on somewhat to Atlantic hurricane activity. This year, El Niño has already decayed away. Enso is in the neutral phase now, headed toward La Niña. We expect to be in the full La Niña by the peak of the hurricane season. And La Niña enhances hurricane activity by reducing wind shear through the tropics. Wind shear can batter a hurricane's structure, helping to break it apart. And that was why this year's hurricane season predictions were so dire. That's exactly the reason why the seasonal forecasts were the most aggressive forecasts they've ever produced. All you can do in forecasts is take the conditions of previous years in simulations. But we've never had a year like this. It is a bit ominous. This year has kind of this perfect storm of conditions, but what about forecasts for future years? The oceans are warming. It doesn't mean that every year, we get warmer than the previous year, but the trend is obviously there. Maybe in 2025 the ocean temperatures won't be as warm as this year. But at some point, it would be nice to get back down to what records used to be. That almost seems like a foreign climate at this point.